Hi, welcome to this lesson on number patterns, sigma notations. In this lesson, we're going to have a look at the property of a sigma notation, specifically the starting index. So starting from a term that is not the first term, what do I mean by that? Well, generally up to this point, our summations have been dealing like this. The sum from I equals 1 to n of your general term ai. So that would start at a and I equals 1. So you would start at 1. That's what I mean by the first term in this case. I equals 1 is a1 plus a2 all the way up to plus an. What happens if you don't start at that first term I equals 1? What if you start at some other number? Let's call it m, right? It could be, you could start at 3, you could start at 7, you could start at 22, as long as you end at some number that's either equal to that number or higher. Right? So what happens if you start at some other number, some other index? Well, how do you represent this? Well, if I say the sum from I equals m to n of ai, it means you start at a sub m. Then what is the next consecutive natural number from m? It's m plus 1. Then what's the next consecutive natural number? M plus 1 plus 1, which is m plus 2. All the way up to a sub n. So we are starting our sum from the mth term and adding up to the nth term. And in general, we generally have that m is less than or equals to n. Right? What does that mean, less than or equals to n in this case? Well, if you had the sum from I equals 5 to 5 of, let's say, I squared, what does that mean? You're starting at 5 and you're ending at 5. Well, it just means you're only adding up one term, 5 squared, which is 25. That's what starting at and ending at the same term means. M is equal to n. But generally, you have that m, in this case, let's say I equals 10, and ends at 20 of I squared. That means you would start at 10 squared and then go up to the next number, 10 plus 1, 11 squared. The next number, 12 squared, all the way up to 20 squared. So we'll have another look at an example there to see how that works. And then an NB here, which is very important. This is not a concept taught enough because it gets taken for granted for. But when you start at any term, I equals m, m could be 1 as well, m could be 2, m could be 3, m can be any starting term. But if you add from that starting term m all the way to n, how do you know how many terms are showing up here in the summation? Because that's important to us. We want to know how many terms are we adding together. Are we adding 2 terms together, 10 terms together, 1,000 terms together? Well, there's a nice, neat little formula which does a little counting principle for us and tells us how many terms there are in the summation. And it goes like this. It's your upper bound n minus your lower bound m plus 1. That's how many terms are in the sum. So if you, for example, look at this example here that I did, I equals 10 to 20, then there would be 20 minus 10 plus 1. So 20 minus 10 is 10, plus 1 is 11 terms. And if you added up all these terms, that's 1 term plus 2 term plus 3 term, all the way up to this last one, you would see there are 11 terms. Let's validate that. Then we know it'll be 13 squared plus 14 squared plus 15 squared, plus 16 squared, plus 17 squared, plus 18 squared, plus 19 squared. So altogether there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms in total that we are summing. So that is the way you can always find how many terms you are summing in that expansion. Let's have a look at this example. Let your general term ai be denoted by I squared plus I, and let m start at 3 and n at 6. Then the sum from the third term to the sixth term is given as follows. So in this general term, you start at I equals 3 and substitute it into there. Plus I equals 4, plus I equals 5, plus I equals 6. And we stop at 6 because that is the upper bound, the n term. And if we add all those up together, we get a sum total of 104. We can also see that we added how many? n, 6 minus m, which is 3, plus 1, which is 4. And you can see that you added 4 terms in total there. 1, 2, 3, 4. Okay, So whenever you start from a term that doesn't start at I equals 1 or k equals 1 or whatever the index variable is, if you're starting at another number other than 1, then you can always tell how many terms are in the summation using this formula here. And you can start by plugging in from that value, and that is how you will do the summation. All right, and that is the starting index property. Okay, I'll see you in the next one.